Today, we're going to be talking about something that's pretty hot right now. We're going to be diving into the world of MLOps.
Oh, yeah.
And
It's a
specifically,
good one.
we're going to be looking at professional certifications
Yeah.
in this field.
Nice.
Yeah.
MLOps is,
If you're out there and you're thinking about maybe getting a certification in this space,
yeah.
this is the episode for you because we're going to be talking all about what it could mean for your career.
Okay, so today we are going to discuss about the PyTorch. Again, it's one of the algorithm for practicing the machine learning, specifically neuron networks and things like that. So as part of it, though you are supposed to know about the neural network, but we discussed in the last two sessions also. So those part I will ignore it, but I'll start with the introduction of PyTorch and related terminologies and so on. So the prerequisite of this course, of course, you should know about a little bit of machine learning algorithms, which you know that I by now, and some of the models, skitlearn, and other stuff. So I think this prerequisite, you are very well aware of it. Okay, so let's move on to the PyTorch. So what is PyTorch? So again, it's one of the deep learning framework for fast, flexible, and flexible experimentations. Again, this is one of the product which is open source. Anyone can go and use it, download it, and start using it. The website is pytorch.org. You can find good amount of information over there about this algorithm. Okay, so what is the background for PyTorch? So it's a relatively new, and then its initial release has happened in the October 2016, but the first stable release has happened in April 2018. Again, this is based on the Torch. Again, the Torch was an open source ML library since 2002. And again, it was initially developed by Facebook AI researchers, and then it got open source and then started by the community, taken care of by the community. Uh, Here, now, this is the one of the algorithm which is GPU ready tensor library. So basically, tensor, I mean, we as part of the PyTorch, the fundamental building blocks are tensors, and tensors which basically learn the from the data. So that is supported for the GPU and CPU. Again, this is a powerful, fast NumPy-like functionality. You have slicing functionality, indexing, reductions, and linear algebras and things like that. Now, this has a very tightly integration with Python. That means without a Python, you cannot use it. That's the reason we call it. Uh, you know, uh, uh, this is like a completely depends on the Python. So deeply tied to Python, approach similar to NumPy scikit-learn, create a neural network in Python, and use existing Python libraries and debuggers. Okay, so in terms of PyTorch is like a tape-based Autograd, uh, which uh, which basically for the learning we require different kind of environment. So that is a tape-based Autograd, and neural network can be redefined dynamically. And here different from the TensorFlow and CNTK. So other neural network algorithms, which is a very popular, which you discussed TensorFlow last time. So it's a different from the TensorFlow and CNTK. Again, it's imperative execution. So you can write a code and same time you can run it. So run immediately and run separate build and run phases, and debugging is easier in this case. Also, PyTorch also offer the ease of extensibility. That means if you want to add a new code, new functionality and all, so this is also easily write a new neural network layers, different alternatives. It can be Torch API, SciFi, and C++ extensions for APIs. And so, what are the major difference in TensorFlow and PyTorch? So again, last session also we had some discussion on this. So TensorFlow is an end-to-end open source platform for machine learning. Again, something similar to PyTorch, but a comprehensive, flexible ecosystem for tools, libraries, and community resources for easily build and deploy ML-powered applications. The website for the TensorFlow is tensorflow.org. Now, what is the fundamental difference between the TensorFlow and PyTorch. So TensorFlow was originally came for the Google, PyTorch from the Facebook. The first TensorFlow were two different two version basically, 1 and 2. Remember that. So TensorFlow is close to PyTorch. TensorFlow 1 is basically you can say it's like a complete different code base and application from the TensorFlow 2. So TensorFlow, the first got released in 2015, and Tensor as a fundamental data structure for computation. So again, Tensor, this the conceptual things is same in the TensorFlow and Tensor PyTorch also. So the building blocks which learns the data and predict the model, which is because we call it Tensor, we discussed. Again, the in terms of where do you run this program. So CUDA support for GPUs. This is the NVIDIA hardware. So CUDA support for GPUs, and again here PyTorch also support the CUDA support for GPUs. What is a CUDA? So it's like one of the acronym is the Compute Unified Device Architecture, which is basically used for the parallel computing and API model created by NVIDIA that allows developer to utilize NVIDIA GPUs for general purpose processing tasks beyond graphics and rendering. So basically, in short, you need a CUDA hardware to run the tensors and learn and then predict the model. So that is something which we have to get it. Again, in terms of TensorFlow, computation graph is static. Here, PyTorch computation graphs is dynamic. TensorFlow must be defined before being run, but it can be defined as you run, as you go and run. Here you have a TF sessions for separation from Python, and it's tightly integrated with the Python. So that's one of the good thing about it. In terms of TensorFlow debugging via TFDBG, here we debug using PyCharm, which is again editor, and PDB. Here visualization using a built-in tensor board. Tensor board, I will cover this tool. It's a separate one. It's another tool actually. So if you want to visualize that, you can use it. But here, if you want to visualize it, you can use a matplotlib and Seaborn. These are the algorithms again for visualizations, graphs and all. Here deployment, you can use the TF serving. So what has happened, like TensorFlow community has developed basically the parallel ecosystem for the everything. So we have a TF serving, TF board, TensorFlow, and many other tools which will help you to implement the complete MLOps. But yeah, again, other products are also very popular as part of this. Here, if you want to deploy the PyTorch models, need to set up a REST APIs using Flask or Django and stuff like that. You can do that. Some of the functions which you can use it like a tf.device and tf.device spec to use GPU relatively hard. But if you want to use the GPUs using the PyTorch, uh, torch.nn data parallel, which is a relatively easier actually. So yeah, learning from PyTorch. So TensorFlow now has a eager execution mode for dynamic graph execution. I just said like TensorFlow 1 and .2. So 2 has a dynamic graph execution, higher level of abstraction to build neural network layers using Keras APIs and things like that. Okay, how do we install the PyTorch? Again, I don't think so I have to tell you this in demo. You know that you can use the pip install and PyTorch, and then installations for the package is done. That's very simple. Okay, so this is the introduction about the PyTorch. Now let's understand how basically it works. So, okay, so working with PyTorch tensors. So as part of these discussions, we'll do the tensor operations using PyTorch tensors. We'll also discuss on the interpretability with NumPy, and then understanding PyTorch support for GPUs and CUDA. And also we'll discuss about the working with the tensors on GPU enabled devices and things like that. Okay, so tensor in PyTorch. So what is a tensor? We discussed like one of the building blocks which basically learns. So central unit of data in PyTorch. A tensor consists of set of primitive values shaped into an array of any number of dimensions. So you can discuss about the multi-dimension data like a 0 dimension, 1 dimension, 2 dimension, 3 dimensions, and also basically these tensors basically understand these dimensions and learn from those data and process through the CUDAs and stuff like that. Okay, so data is represented as tensors and in a form of 0D. 0D means zero dimension. So usually when you want to represent the scalar data, which you can call it a zero dimension. So a scalar data, something like 3 is a scalar data, 6.7 is a scalar data, alphabet is one scalar data. So if you want to represent as a scalar, it's called a zero dimension tensors. Okay, so and now if you see that here is a one dimension tensors. So these are the vectors. Vectors are one dimension tensors. So if you see that you have a parenthesis, so inside that you have a one dimensions like 1, 3, 5, 7, 9. So all together is called one dimension. So this is how you represent the one dimension. You can also, so here we did the scalar, here we did the vectors, here we have a matrices. So how do you represent the matrices in PyTorch? So PyTorch matrices are represented in two-dimension tensors. Okay, so if you see that here, you have a two-dimension tensor below, and you use a double square bracket for that representations. So matrices are a two-dimension tensors, and this is the representations for this. Okay, so PyTorch tensors have been architected to make optimal use of GPUs for massive parallel computation. So yeah, this is one of the kind of algorithm framework which you can say, which has been designed to run and learn from the existing data parallelly, and to give you to give the speed of processing. So this is something which has been uh, designed. Now let's discuss about the PyTorch, CUDA, and GPUs. So what is GPU? I think we all know this. GPU stand for graphics processing unit, specialized chip with highly parallel architecture that makes them an order of magnitude faster than CPUs for some deep learning applications. PyTorch tensors have been architected to make optimal use of GPUs for massively parallel computations. GPU for ML, yes. So what are the use cases for it? So uses of GPU has gone far beyond videos and graphics processing. Nowadays, we use widely used in big data and machine learning applications, and speed up of 10 to 15x where parallelization yields big win. So because of GPU, this will help you to run all the requests parallelly up to the 10 to 50x. So that's the way you have the faster results. What is CUDA? So yeah, again, it earlier it used to be one acronym, but now you can call it directly CUDA. No need to know the full form and all. So yeah, CUDA, it was a kind of, you can say, the the component. I mean, it's kind of product line of NVIDIA, uh, which is basically who's a major maker of GPUs, and devised CUDA, a parallel computing platform and APIs, standard for general purpose non-graphics users of GPU. Initially a acronym for Compute Unified Device Architecture, but now you can call it a CUDA. It's now a standalone term, not an acronym. So CUDA and with PyTorch. So yeah, developer can write a CUDA compliant code. That means whatever the code you write, it has to be CUDA compliant. There are some specifications for that. So CUDA must be understood by the code must be understood by CUDA aware framework like a PyTorch. So PyTorch, TensorFlow, and many other libraries, which is basically CUDA compatible framework actually. So if you write a program, automatically it will become a CUDA compatible. So if CUDA enabled GPUs are available, speed up will automatically occur while you are running. Now, downside, I have given one list of framework which is a CUDAware, which include the PyTorch and then TensorFlow as well. Okay, so now what is the function to use it? So torch.CUDA for CUDA operations. Special tensor type for CUDA example torch.CUDA flow tensors. Torch.CUDA device to select the GPUs and track currently selected GPUs and create tensors on it. Okay, so in terms of cross GPU operations, which is not allowed by default, so in CUDA with PyTorch, so exceptions like there's a certain exceptions, which like a copy functions to CUDA and other methods with the copy semantics. Operations on tensors across devices will cause error, so can mitigate by this by enabling peer-to-peer memory access. Okay, so how this PyTorch works with the CUDA? What are the mode of communication? So this is having a sync execution. So executions is sync, whereas GPU operations are async used by default. Enqueued to particular device executed later. That means any request which is coming, it's been queued and then executed based on the availability of the devices. So allows execution on many more computation in parallel. By the way, this async execution is a default. You can make it a sync also by changing the code, and that's primarily for use for troubleshooting actually. So yeah, just a second here. So yeah, you can force async execution using environment variable, that's CUDA underscore launch underscore blocking is equal to 1. So if you set this variable, environment variable, then it'll become a sync 1. Useful for error handling and examining the state traces, and functions such as to copy, allow, non-blocking arguments and all. Okay, CUDA streams. So how the CUDA streams work? So in terms of CUDA streams, linear sequence of operations for execution on single devices. By default, each device has a default streams. Operations within the streams are serialized by PyTorch. Order is deterministic. Order of execution across the streams is not deterministic, and so on. Okay, so in terms of how this PyTorch will write a device agnostic code. So device agnostic code explicitly handle the GPU and CPU cases. Common pattern is to use argpass to read user argument. Code can then be invoked with the runtime flags to enable the and or disable the CUDA. This is something which we will do the demo part. So this was the introduction of PyTorch. Any questions you have on this?